In this quick tutorial, I will show how to create an Omnichain contract that withdraw tokens back to the original chain from which these tokens were sent, and that is compatible with Bitcoin. We're going to focus on the Bitcoin compatibility aspect of this. So let's start with a template. First of all, clone the template from ZetaChain's GitHub repository. So ZetaChain/template. Once you have it cloned, open it in your text editor. So this template is a good starting point for your cross-chain messaging or Omnichain project on ZetaChain. First, install dependencies, and once that's done, you're ready to start building your contract. We're going to use npx hardhat omnichain command to create a new contract, and we're going to call it withdraw. It will not use any additional arguments. It's going to be a very simple contract. Let's check it out. So we see that this command created a contract for us. It doesn't do anything. It just implements basic on cross-chain call function that will be called when someone sends tokens to a TSS address on a connected chain. So let's implement the logic. First of all, what we want this contract to do is when a person sends BTC on Bitcoin testnet to a TSS address, we want to trigger this contract, and we want to get the recipient address, so the same address from which the tokens were originally sent. So if this was an EVM-based chain, we would just use the context variable and our origin property, which contains the sender address, hexadecimal sender address. For Bitcoin, it's a bit different because the context origin does not contain the original batch32 Bitcoin address. Instead, it contains the first 20 bytes of the hexadecimal representation of the batch32 address. So it is an identifier, but it's not an address. You can't derive the address from that value. So we need to pass the address in the message content. So our message will be very simple. It's just hexadecimal representation of batch32. So let's create a bytes variable stored in memory called recipient that will contain bytes. So normally we would say 20 bytes, but for batch32 it's actually 42 bytes since it's longer. Now we want to take the first 42 bytes from the message and put it in the recipient variable. I'm going to use the for loop for that. So uint and yeah, auto completes for me. So put it in the recipient variable. Now we have the recipient. Okay, simple enough. Now what we're going to do is we need to determine gas fee, because withdrawing tokens, depositing tokens right now is free, but withdrawing tokens actually takes a gas fee. So let's use zrc20 and pass the zrc20 address, and has a function called withdraw gas fee. This returns two variables. We don't need the first one, which I'll just ignore, and the second one is uint256, and it's actually the gas fee. Okay, so we'll use this gas fee next step. Now we need to approve the zrc20 contract. So zrc20 approve the gas fee amount. And now we can actually withdraw. So zrc20 contract has withdraw function that essentially burns the zrc20 and instructs ZetaChain to send the appropriate amount to the recipient from the TSS address. So we'll deduct the gas fee from the amount. Amount is the amount of tokens we're sending to the contract, and that should do it. So again, this contract just you just deposit tokens into this contract and it sends tokens back. So it's not very useful, but it shows how to actually get the tokens back to the Bitcoin address. So you need to send it in the message and pass this value back to withdraw. So you can't use context origin, but you can use the message for this. Okay, so now that's done. We need to pass the hexadecimal address to this contract call. And to do this, let's write a very simple helper function that will allow us to do this. We don't need the interact task because it's going to be just sending transaction on Bitcoin, so we don't need to interact directly through hard hat. We're going to use a command for this. So let's import utils package from utils from ethers package, and utils has this function called to UTF 8 bytes. So utils to UTF bytes, and we can just pass the args address. So we're passing it as bytes, and then utils also has a function called solidity pack, which just helps us pack the values in a bytes format. Okay, so this should do it, and we need to add a positional parameter called address just to make it easier for us. And let's call this address. Okay, so now that that's done, we can actually try it out. So first of all, we need to know what is our Bitcoin Batch32 address. We're just going to query balances and get the output. So here it is for me. And now we can use the address command to actually get the hexadecimal representation of it. So the origin, context origin, by the way, is just 20 bytes of this string. So it's somewhere around here, right? But we need to pass the whole address so that we can withdraw to the proper address, right? So now the way you would call a withdrawal contract like this is you would send tokens to a TSS address. So we have a function for that, command send BTC, and you can read more about it, but essentially it requires an amount. We're going to send just a small amount. It requires a recipient, which is a TSS address. You can get it from the docs, so zetachain/docs. You can go to the reference section and it's labeled as BTC. So you can copy and paste this TSS address, and then you're passing a memo. So for the memo, oh, okay, we forgot to do something. Let's do that first. We forgot to actually compile and deploy the contract. So let's use hard hat compile with force flag to compile the package, the contract, and now we can deploy it to Zeta testnet using bx hard hat deploy. You will need Zeta tokens for this on Zeta chain, so use the faucet to get tokens. My account already has it. So, okay, now going back to our send BTC command. So the first part of the memo is always the contract on Zeta chain without the 0x prefix. And after the contract is the value. In our case, the value is the hexadecimal representation of the Bitcoin address, so we just paste this. This is a pretty long memo, but it should be fine. So yeah, this looks good. So we have this contract deployed. We're now sending BTC to this contract with a memo. Confirm that we want to send it. We'll respond with the transaction hash. You can go to any Bitcoin testnet explorer and check this transaction out. It should get around 3 confirmations, I believe, for this to be processed by ZetaChain. You can also use a built-in cctx command to track it. Make sure that you have installed the latest version of the toolkit, so yarn add ZetaChain toolkit just to make sure. And now you can use npx hardhat cctx to track this transaction. So it's going to look for it on ZetaChain, and when it is processed, when it gets enough confirmations and it is reflected on ZetaChain, you will also be able to see if everything is successful. You will see 2 transactions. One is inbound from Bitcoin to ZetaChain, calling the contract, and the other one is outbound from ZetaChain to Bitcoin, withdrawing tokens. So it's going to happen in one call, but you will see 2 transactions. So that's it. We're not going to wait for this transaction to go through, but it might take a while before we get the right number of confirmations. But this should allow you to kind of better understand how to build a simple contract and how to pass Bitcoin address. You probably need to pass it almost for every project, because at some point you would want users to be able to withdraw tokens. So this is one way to do this. So yeah, thanks for watching. And if you have questions, feel free to join our Discord. There's a dev general channel, and I will be happy to help you there. Thank you.